Welcome to the session. In this session, we are going to discuss about the types of files that are available in Unix. In the last session, we have discussed about the file structure of Unix. Actually, a file contains a collection of information. Okay, this information is nothing but processed data. Information is nothing but processed data. Data is nothing but collection of raw facts. So data can be defined as a collection of raw facts. Processed data is nothing but information. So file contains collection of information. Okay. Unix treats everything as a file. It also treats the hardware components also as a file. Okay. Next, coming to directory. Directory also contains collection of subdirectories and files. Okay. So totally we can say file contains collection of information. Today we are going to discuss about the classification of files. Okay. In Unix operating system, based on the significance of contents that are available in a file and the permissions that are granted to the files, Unix files are classified into three types. They are regular files, directory files and device files. So file contains collection of information. Here we are saying the permissions granted to files. Actually each and every file contains three types of permissions. Means read permission, write permission and execute permission. Means read permission means we can read the content from a file. Write permission means we can write the content into the file. Okay, it allows the user to write the content into a file. Similarly, execute permission, to execute the code that is available in a file. So each and every file contains three types of permissions. Those are read permission, write permission and execute permission. Okay, so in Unix operating system, by using various commands, we can assign read permission, write permission and execute permissions to files. Similarly, we can remove the permissions like from users. Three types of users are available in Unix operating system. We already discussed in the previous sessions. Okay, owner, group and others. Okay, from these users we can remove the read permission, write permission and execute permission. Similarly, we can assign the read permission and write permission and execute permission to these three types of users. According to our wish, we can assign the file permissions and remove the file permissions from these three types of users. This is about the permissions given to files. So based on the significance of information that is available in a file and the permissions granted to the files, Unix file system is classified into three types. Unix files are classified into three types. Though they are regular files, directory files and device files. These device files are also known as special files. Okay, so based on the significance of the contents of the file and the permissions granted to the files, Unix file systems are classified into three types. They are as follows. Those are regular files, directory files and device files. So totally we can say file contains collection of information. We can assign the permission to files. Similarly, we can remove the permissions from files also. Okay, this is about the file. Now we are going to concentrate on what do you mean by a regular file and what do you mean by a directory file and what do you mean by device files. Okay, so here we have to observe these 2 points based on the contents of the file and the permission given to or permissions granted to the files. Unix files are classified into three types. Okay, first one is regular file, second one is directory file and the third one is device file. This device file is also known as files are also known as special files. Okay, what next we have to concentrate on what do you mean by regular file and what do you mean by directory file and last one device files. Okay, first one is regular file. Okay, regular files can be created by users. Regular files are also known as ordinary files. Actually, file contains collection of information. Regular file means it can contain either text or program or some commands. Okay, a file which contains collection of text information, that is known as text file. A file which contains collection of code, means set of statements and instructions, that is also known as a regular file. Similarly, a file which contains commands, Unix commands, that is also treated as a regular file. Okay, totally we can say a file which is a randomly addressable sequence of bytes is known as a regular file. A file which is randomly addressable sequence of bytes is known as a regular file. These files can be created and deleted. Files are created by whom? Files are created by user only, according to user's wish. User can create a file. User can create a text file. User can create a program file. Or user can store some commands in a file. That is also known as regular file. Okay, so we can treat this regular file as a ordinary file. Okay, it contains text information. Okay, also known as a text file. A file which contains only text, that is known as a text file. Next, a file which contains source code or programs. Source code like C code, Java code, like C code, Java code, Python code. Is treated as a regular file. Similarly, files which contains Unix commands is also treated as a regular file. These regular files are also known as ordinary files. Means it contains this type of information like text, programs and Unix commands also. Okay. Unix treats everything as a file. It also treats each and every hardware device also as a file. Unix treats every hardware component also a file. Okay, so these files are also, regular files are also known as ordinary files. Regular file contains either text or code. Code means a program. Okay, next it also contains commands. Okay, these files are created by user and deleted by user according to user's wish. Okay, means we can create a file. Similarly, we can remove the file according to our wish. So regular files are also known as ordinary files. Regular file contains text, programs and commands. Okay, this is about regular file. Next. Second one is directory file. Okay, we already discussed about what do you mean by a file and what do you mean by a directory. File contains what? Collection of information. For example, here I am taking one file, sample. Okay, it contains text. That's why this is this file is without extension. For example, take one more. Sample.c. This is also treated as a file. Okay, here we are saying directory files. Directory files means actually Unix file system is maintained in a hierarchical manner. Hierarchical structure means one-to-many combination. Okay, this is the first one is the root. Okay, this is the parent one, and all the files and the subdirectories, directories, everything can be created under this root only. Okay, so all these are known as descendants of root. Okay, this is the first one, parent one, root. Under root, directories. Under directories, we can create either subdirectories or files. Okay, this is the parent one and all these are descendants of the root. Okay, this is known as directory. For example, here bin is one directory. Under bin, here sample.c, this is file. Okay, this one is treated as file and this one is treated as a directory and this one is treated as a root. So a directory can contains collection of subdirectories and files. Okay, a file which contains organizational details of files. A file which contains organizational details of files is known as a directory or a directory file. Okay, directory files can also point to some subdirectories and files. Means under directory we can create either subdirectories or files. Totally a directory can contain either subdirectories or files. So it contains collection of information about the files. Means date and time of file created and file capacity, directory capacity, everything will be noted under the directory file. Okay, so directory file can contain two important points. Those are each and every directory file contains file name and file identification number. Okay, each and every file can be assigned with one name, that is known as a file name. Similarly, each and every file is identified by one number, that is known as identification number. File identification number, also known as inode number. Inode stands for identification number. Okay, each and every file can be identified either by using file name or identification number. This directory file contains the information about these two, means each and every file name and each and every file identification number is all to be stored in a directory file. So directory file contains the information about the file name and file identification number. File identification number is also known as inode number. So directory can contain collection of files and subdirectories. So a file which contains organizational details of files is known as a directory file or also known as a directory. Okay. Directories can also point to some other directories, means under the directory we can create either subdirectories or files. So directory contains subdirectories and files. Okay, this kernel is going to manage all the directories and subdirectories whatever the user created. Okay, so kernel manages the directory files. Each and every directory file contains the information about files. Okay, those information are file name and file identification number. Each and every file can be identified by identification number and each and every file can be recognized by using the file name. Okay, each and every file can be saved by using the file name only. For example, here I am creating the sample.c, means I created one C program file and saved that file by using a file name sample, and extension of C program is .c. Okay, sample indicates file name and C indicates this is a C program. Okay, this is the identification. This by just by observing the file name and extension we can say that file is a C file. For example, if it is a Java file, extension is sample.java. For example, if it is a C++ file, we can observe sample.cpp. For example, if it is a Python file, we can recognize just by observing the extension of a file. Okay, so each and every file can be identified by using the file name and file identification number. So directory file contains the information about these two things, means file name and file identification number. This is about directory files. And the last one is device files. Device file means a file which is a point of interaction to one of the computer hardware devices. Okay, the computer hardware devices are keyboards, disks, peripheral devices. Peripheral devices are also known as I/O ports. Okay, here I/O ports are also known as peripheral ports. Hardware devices are I/O devices, disk devices, memory, all these treated as device files. Okay, a file which is a point of interaction to one of the computer hardware device is known as device files. Okay, device files are random access memory file and disk drives and I/O ports. It acts as a communication channel between two or more operating programs. Unix treats each and every hardware component as a file. Is the main feature of a Unix operating system. It treats every hardware component as a file. That is the main feature of a Unix operating system. Here I/O ports means peripheral devices, and disk drives, floppy disk drives, compact disk drives. Next, random access memory, RAM. Okay, all these are treated as device files. Okay. Next, device files are classified into two types. Device files are once again classified into two types. Those are character special files and block special files. Okay, first one is character special file and the second one is block special file. What is the importance of first character special file? Okay, the files which are used to model I/O devices are known as character special files. Okay, the files which are used to model I/O devices. I/O devices means input-output devices. The devices which are used to the files which are used to model input-output devices are known as character special files. That is the main feature of characters to model I/O devices. This is the main feature of character special files. Okay, we can say the character special file as a file which is used to model I/O devices is known as character special file. Okay, examples are terminals, printers, keyboards, plotters, keyboards, everything can be treated as character special files. So the files which are used to model I/O devices, are known as character special files. Examples of character special files are printers, plotters and terminals. Okay, and the second category of device file is block special files, means the files which allows block of data to be read from a device. Similarly, block of data can be sent to a device. Mean, for example, if you take a pen drive, also one example for this block special files. We can read the data from pen drive, means we can read block of data from pen drive. Similarly, we can send a block of data to the pen drive. Okay, so whenever there is a need for us to read block of data from a file, similarly, whenever there is a need for us to send block of data to a device, then that can be considered as block special file. Okay, the files which allows blocks of data to be read from a device and similarly to send blocks of data to a device is known as block special file. Okay, examples of block special files are disk drives and magnetic tapes. Okay, here disk drives, compact disk drives, floppy disk drives are treated as block special devices or block special files. Okay, so Unix treats every hardware component as a file. Okay, this is about types of device files. So today we discussed about the types of files in a Unix operating system. Okay, file contains what? A collection of information. Information is nothing but processed data. Data is nothing but collection of raw facts. So first point is, first you have to concentrate on what do you mean by data. Data is nothing but collection of raw facts. Next, we have to consider information. What do you mean by information? Information is nothing but processed data. Processed data. Okay. Next, what do you mean by file? File is nothing but collection of information. Similarly. Next, what do you mean by a directory? Directory is nothing but which contains collection of subdirectories and files. Collection of subdirectories and files. These are the basics of files. Okay. Data is nothing but collection of raw facts. Information is nothing but processed data. File is nothing but collection of, file contains collection of information. Directory contains collection of subdirectories and files. Okay, these are the basics. So today we discussed about files, types of files. Okay, first one is Unix file system is classified into the 3 types. Okay, those are regular files. Second one is directory files. Third one is device files. Okay, regular files are also known as ordinary files. Ordinary files. Example, regular file contains either text or source program. Next, Unix commands. A file which contains text is treated as regular file. A file which contains source program is treated as regular file. A file which contains Unix commands is also treated as regular. All these are treated as regular files. These regular files are also known as ordinary files. Okay, these are the examples of regular files. Second one is directory files. Directory file. Directory can contain collection of subdirectories and files. Okay, Unix file system is maintained in a hierarchical manner. Means one to many combination. The top one is denoted by root, forward slash, that indicates root. Under the root only we have to create the directories. Under the directories only we have to create the subdirectories and the files. Okay, each and every directory file contains information about file name and file identification number. Each and every directory file contains file name and file identification number. Also known as inode. One of the important concepts in this unit is inode. Okay, each and every directory file contains the information about file name and file identification number. And the last one is device files. Device file is nothing but point of interaction to one of the computer hardware devices. Okay, so device files are once again classified into 2 types. Those are character special files and block special files. Character special files and block special files. Okay, next, what do you mean by character special files? A file which is used to model I/O devices, means input-output device like keyboards, printers, plotters, all those are known as character special files. A file which is used to model I/O devices. Okay, to model I/O devices are known as character special files. Examples, terminals, printers, plotters, all these are treated as character special files. Similarly, block special files. Whenever there is a need for us to read block of data from a device, that is known as a block special file. Similarly, whenever there is a need for us to send block of data to a device, that is also treated as block special files. Okay, examples, disk drives, magnetic tapes, bulk amount of data we can store in these devices. By using these devices, we can read the data. Similarly, we can send the data into a device. That is the main importance of device files. These are classified into 2 types: character special files, block special files, which is used to a file which is used to model I/O device are known as character special files. A file which is used to model these disk drives, magnetic tapes are known as block special files. Totally 3 types of files in Unix file system. Okay. Thank you.